But this one, you can't easily solve for y. So we need a way that we can find the derivative without putting it in explicit form. That's what that says. Okay, so if we have y equals x squared plus x plus 1, we want to take the derivative. The derivative of y is 1 dy over dx, because we're taking the derivative with respect to x of y. The derivative of y would be 1, but then we don't have, this isn't x, so the derivative of y is 1 dy over dx, the derivative with respect to x. Derivative of y with respect to x. The derivative of x squared is 2x, derivative of x with respect to x. The derivative of x is 1, derivative of x with respect to x, derivative of 1 is 0. Okay, so we have been writing this dy over dx or y prime or something like that. Dy over dx equals 2x plus 1 because those dx over dx's cancel out. But we really are taking the derivative of the y term and writing dy over dx. When we've been doing that, we've been taking the derivative of that y term and writing it dy over dx or y prime or something like that. Okay, so that's still confusing. I made a new slide this year. Find me?
How do they agree?
This one's x and that one's x.
Okay.
Because they're both x, I'm taking the derivative of x with respect to x. So it would do that canceling out thing, dx over dx cancels. Because they agree, I can just write it 3x squared. But if I'm taking the derivative of y cubed with respect to x, that's going to be 3y squared. And then because that's not x, I have to write dy over dx. Because the variables disagree, I have to take the derivative of y with respect to x and write that right there. So when the variables disagree, what we're really doing is using the chain rule to differentiate the variable with respect to x. So we take the derivative of this function with the y still in it, and then we take the derivative of y with respect to x and write it next to it multiplied. Kind of like if we were doing the derivative of we don't know how to do that yet, do we?
How about sine 2x?
There you go, thank you. You take the derivative of sine, which is cosine, you leave the 2x there, and then take the derivative of the 2x, which is 2. We're doing the same thing here. Take the derivative of y cubed, which is 3y squared, and then take the derivative of y, which is dy over dx. Okay, so if we want to take the derivative with respect to x of this, x plus 3y, we start by taking the derivative of x, which is 1, and the variables agree, so I don't have to write any of that dy over dx stuff. Then you take the derivative of 3y, which is
3 dy over dx.
3 dy over dx, because the derivative of 3y would be 3, but the derivative of y, you have to write like that.
Dx.
Oh, it's dx.
Yeah, sorry. Thanks, guys. Okay, so the next one, I have two functions multiplied together, so I need to use
The product.
product rule. So we're going to do the first times the derivative of the second, which is 2y
dx.
dy over dx, plus the second times the derivative of the first. Everybody understand what we're doing on this one?
Is there anything in that cancel out, or is that going to be
This is. Take the derivative of y cubed,
3y squared.
3y squared, but we are doing derivative with respect to x.
Yes.
When
So
we take
dy
the derivative,
over
we want it
dx.
with respect to x. So since those don't agree, we have to write dy over dx. The derivative of y squared,
2y dx.
the derivative of negative 5y.
dx. Minus 2x.
Isn't the derivative of that 0? It's not.
Of this is 0.
Of 5.
Negative
5y.
5y.
Oh, yep, alright.
Okay, so now we need to get the dy over dx is all on one side so that we can factor it out, because we want to end up having for our answer dy over dx equals, so that it'll be derivative of y with respect to x equals something. Because that's what we've always been trying to find, the derivative of y with respect to x. So,
2x over 2.
you can't do that
Did you move 2x to the other
on
side?
this.
Too
You
complicated.
moved 2x to the other side, right?
Yeah, move,
So move 2x to the other side.
and then divide by everything else.
Let's see if I should have fast again, that's me having.
Yeah, it is very fast. And
If I write fast.
Factor out the dy over dx.
Actually, apparently, when I write slow, someone
Yeah.
very long.
To get dy over dx by itself, divide by all of this.
Me? Freshman year, load slow, and you apparently second, it's like parallel. One of the freshmen was writing really slow, and tried to let me, and he said, Harry Potter. Yeah. My handwriting.
So is that our answer?
Yes.
It looked like his handwriting from.
So now we know the derivative is this.
Yeah.
Okay, yeah, and there's probably no way.
3 something squared, the derivative of 3 something squared.
Is 6.
6 something
Something.
to the first. Times this derivative of the something.
Oh man.
2y plus 2.
2y dy. Oh, dy
Ah.
plus 2x.
That's so frustrating.
I don't know. The chain rule.
Oh.
Where she did like the main outside part and then the inside part.
100.
The inside part had y and x in it. So you
Plus
have to do that.
1
I just got it.
And now we have 100 x times y. The derivative of x times y you have to do
Remember Brian knows.
product rule
product rule.
times y.
Okay.
No.
First times the derivative of the second, which
What?
is 1
dy.
dy over dx. Plus the second times the derivative of the first. Derivative of x is 1.
Oh boy. Hmm.
This is
Oh.
Now we have to
Wait,
get the
that
dy
looks like
over
maybe
dx
it's
by
supposed to
themselves.
be y.
Wait, why is it
Why
x
does it look
dy
like it's
over
opposite?
dx?
because
The
it's
derivative-
of y.
It's first times the derivative of the second. Derivative of y is 1 dy
Oh,
over
you
dx.
did it
Product rule.
when.
Wait, Nathan.
I just,
He's
Sure you?
this one. I didn't say I knew it.
Pretty sure you did.
I just don't get why dy over dx is right by x.
No,
It's
it's
the
the
F
first times derivative of the second, which
F
is y.
times derivative.
X times derivative of second, which is dy over dx.
Lunch.
This whole
What?
thing
Are you doing anything
distributed
for lunch?
here.
Oh.
This whole thing
That's
distributed here.
Oh.
So
I don't
then I
think so.
have
Basically.
6.
So when you find
I
the
would just put
derivative
all that
of
out in
y
front.
Mm-hmm.
Or something
12 y
You just do it the normal way.
dy over
And then
dx
next to
times
dy
y
over
squared.
dx.
But why? What does that mean?
Derivative
Plus
of y in respect
12x.
to x. So when you do derivative of x in respect to x, it's like the same variable.
Why?
So you don't have to
So
FOIL
don't-
it, you just have
so
to put it in
just
front?
You don't need it. But if you're finding the derivative of y,
Oh, I see what you're doing.
say if you're finding the derivative.
Oh, like if you're finding. Like if you're finding. What is this?
We want the dy over dx's together, so I'm gonna move this one over.
But that doesn't cancel at all.
I don't know which
Okay,
Well, I
like
guess
if
I
you're
could distribute.
finding the
100?
derivative of like 2.
ones are harder. Great.
Holy
I'm
cow.
just saying,
Yeah, and that went.
Ellen, move your
This
head.
one's harder.
Oh.
What?
Oh, there it is.
But
Just
normally-
different type of
I
problem.
got it.
Oh, wow, that's great.
This one,
It's gonna take
can
an
you
hour
just
for
rearrange
it
it
to
and do that, or no?
Alright, so we just start off by finding
It will be ugly. You
Time for
can
it to
square
work.
root
Oh,